Yes, welcome, my dear students. Today we are coming to look at the third component of computer system, where the other time we looked at the computer softwares, and now we're at data communication. We're just basically going to be for 30 minutes, and we shall proceed tomorrow for our face-to-face class. Now, when we are introducing the computer component, the computer system, we said a computer cannot be a full system when it lacks data or it can't communicate, maybe within itself or between the computer and another. So, just like a human being, when the communication between you and the other person fails, then the relationship fails. So, communication in a computer is very important. So, what is data communication? Let's look at the way humans communicate. The idea is the same. So, data communications is exchange of data between two devices. The devices can be computers, it can be phones, it can be network infrastructure. So the exchange of information from one to the other is what we are terming as data communication. What are some of the terms that are used in data communication? One, we have data transfer rate. When we talk of a rate, the transfer rate, at this time we are talking of the speed. So the data transfer rate is the number of bits transmitted between a source and destination in 1 second. So what are bits? At the beginning, we looked at the memory units. And the bit was the smallest unit of data. So, in a second, if more units of data are transferred or transmitted from one device to another, then it means the speed is higher or the transfer rate is higher. So when the number of bits transmitted is small, meaning when the quantity or amount of data, smallest unit of data transmitted is small, then the transfer rate is lower. So the higher the transfer rate, the higher the speed, or the faster the speed in the communication. So the data transfer rate is also known as bit rate or data transmission rate. The bit rate or the data transfer rate or the data transmission rate is measured in terms of bits per second, which is in bracket BPS. Then we have a transmission media. Like in communication, a media is anything that aids in the communication between the two people. The method or the way that one person uses to communicate with the other is the medium. For example, I can choose to communicate with the other person using telephone. Then the telephone becomes a media. Or I can choose to communicate with another using letters. Then the letter becomes a medium. I can choose to communicate with other people using radios. then the radio becomes a medium. So that concept also applies in the data communication in computers. So the medium can be physical or it can be non-physical. A physical transmission medium is the one where the path, a dedicated path is established. That is communication through the cables or wires. For example, when you are sending something from your phone to the computer using USB cable, that is physical. But if you are using Bluetooth, then that is non-physical. Using Wi-Fi, the wireless fidelity, that is non-physical. And if you are using the cables like the Ethernet cable, the twisted pair cables and so on, that is physical. Then another term that we can look at is data signal. The data that moves from one computer or between computers moves in form of a signal. But what is a signal? A signal is just simply any electromagnetic energy that represents the flow of the data. Another term that we can also look at is modulation, as well as also demodulation. Modulation is a process of converting a digital signal to analog during transmission. This is done by a device known as a modem. When we are looking at the types of computers, somewhere we said the types of computers. One, we looked at the hybrid computers, we looked at the digital computers, and then we also looked at the analog computers. So that comes in the way they function. The analog computers are the computers that represents data in a continuous form, in a measuring or measurement quantities. Then the digital computers represents data in a discontinuous form, in a binary form, or in bits, or the data is represented in bits. So when that concept also applies in the modulation or in the communication, when data moves, when a data is sent from one computer to another, it may sometimes need to be converted from being from one form, which may be analog, to another, which is digital, or from digital to analog. So the process of converting the very signal of a data from being digital to analog is modulation. Then the demodulation is reverse. It is a process of converting a modulated signal to a digital signal. So a modulated signal is simply an analog signal. Another term that we can look at is multiplexing and also demultiplexing. Multiplexing is a process of sending multiple signals over the same media, while demultiplexing is the process of separating the multiplexed signals at the receiving end. So during multiplexing, very many different signals could be sent using the same media, meaning using one path, for example, if it is a cable. But now at the receiving end, the different signals will have to reach to their different destinations. And that's the reason for which the multiplexed signals are separated so that they are able to reach to their different destinations. Then we have a baseband signal. This is a digital signal that is generated and applied to the transmission medium directly without modulation. So this is a digital signal that is just that is generated and it is transmitted without being converted to analog first, so that it is able to move in analog form. No, the digital signal moves as a digital signal. So meaning without it, modulation is converting it to analog first. Then the bandwidth is the maximum amount of data a transmission medium can carry per second. Maximum amount of data a transmission medium can carry per second. So the bandwidth shows about it's about the speed of it. The bandwidth determines the speed of communication when a transmission medium is used. Let's look at a road. If a road has one lane, meaning the maximum amount of or the maximum number of cars that can be used on the road per second may be 1. Then it means the bandwidth of, if we are to say the bandwidth of the road will be 1 car per second. But now the road that it has 2 lanes, we say the maximum number of cars that can pass on the same road in a second are 2. Then if the road has 3 lanes or 4, then the maximum number of cars that can pass on the same road in a second or in the same second can be 4. So now at the end of it, you find a road that has 4 lanes will ever allow more cars to pass at the same time, at the same second, than one that has 1 lane. So in this case, a transmission medium that has a large bandwidth will always allow faster communication than a transmission medium that has a small bandwidth. Then we look at the next term, which is attenuation. Attenuation is the reduction or decrease in the magnitude and energy as signals progressively move along a transmission media. So attenuation is actually a problem that occurs in the communication. When a signal is passed through a communication medium from one to another, as these signals move along the medium, the longer they move, the more weaker the signals become. So that reduction in the magnitude or the power or the level as the signals move along the medium is attenuation. For example, let's say there is someone who is here within Ovujo and they would like to communicate to someone who resides in Arua or Nyadre. So you generate the signal of your communication, and then it begins to move from your end. It is strong, but as the signals move along the path, they keep dropping, reducing, and at the end of it, the communication may fail or it may be weak. So that problem where the energy is lost as the signals move in the along the transmission medium is attenuation. Then a throughput is the number of messages that are successfully delivered per unit time. Then we also have a packet. A packet is piece of message transmitted over a packet switching network. So when you send a message, a piece of the whole message is known to be packet. A packet switched network is a type of network that groups and sends data in form of small packets. So in a packet switched network, data is sent in small units, and which units are known to be as packets. So one data is broken into small pieces, and those small pieces that are broken are known to be packet. So packet switching is a digital network transmission process in which data is broken into suitable sized pieces. So the suitable sized pieces are what we call as packets. So meaning in the transmission process, the data is broken into small pieces, and these pieces are packets, or in blocks for fast and efficient transfer via different network devices. So one major reason of breaking data into smaller pieces is only to increase the data transfer speed. Latency is the amount of time it takes a packet to travel from a source to a destination. Amount of time it takes a packet to travel from a source to a destination. So if it takes for you to move from, say, Arua town to Ovujo, if it takes 5 hours, then that time, which the 5 hours time that you have taken to move from Arua to Ovujo, is the latency. So the amount of time it takes a packet, let's say now the packet is you, to move from the source, that is Arua, to the destination of Ovujo, that time taken for the data to travel is latency. Then next we have data terminal equipment, which is abbreviated as DTE. This refers to any device equipment that is either a source or a destination for digital data. So any equipment that is used for digital data is the data terminal equipment. So the most important thing is the equipment should either be the source or the destination. The source is where the data is coming from, and the destination is the device to which the data goes, or where it arrives. A node, NODE, refers to any device on a network. So this can be a source device, it can be a source equipment, it can be destination equipment, it can be any other. So any device, anything that is included in a network becomes a node. For example, a switch is a node, a hub is a node, a router is a node. So basically anything, even the phone becomes a node when it is connected to the same network. The computers becomes nodes. So basically anything that is connected to a network is a node. Then band rate. Band rate is number of signal units transmitted per unit second that are needed to present the bits. Then data communication equipment. These are equipments that transmit or receives analog or digital signals through a network. Then lastly, we have the IP address. IP address is a protocol that controls and manages the data transmission over internet. So IP in full is also known to be as Internet Protocol. This is basically set of rules. Protocol is a set of rules that manages or governs a network. So what are some of the importances of computer communication? Importances of allowing computers to communicate. One, it allows the sharing of hardwares like printers. So if two or more computers are able to communicate between or among themselves, you find the computers that are able to communicate between themselves can share one hardware. Like there's one printer, yet the 5 computers in the office are able to communicate among themselves. So the one printer can be used by the 5 computers simultaneously. So second importance is it allows the sharing of software between 2 or more computers, hence reducing on the cost. So when the computers are able to communicate, one software can be installed in one computer. A software can be installed in one computer, then others now may be communicated on the the one software is used when they are communicated. They are interconnected together, or in the same communication. For example, a software that is installed in the cloud allows all other computers to use the same software when they are connected to the same network. It allows the sharing and the transfer of data and information stored on other computers on the network. So the computer communication allows the data to be shared from one to another. Facilitates communication between people. For example, emails, mobile phones, like also WhatsApp and so on. Then ensures security of data. Computer communication allows data security and control. Then it enables online learning and collaborative research. When students, for example, for their holidays, can continue to learn with their colleagues with the help of their phones or with the help of their computers in this era of technologies such as Zoom, Google Meet, and so on. So it also allows access to common databases. For example, in banks, a database where information of several people are kept, many people also can access that database at their own convenient time, and that is only possible with the help of 2 or more computers being connected together to make a communication. So without that, it will not be easy to access such databases, to get such information. For example, right now you can log in and just find out or get in some information related to your NIN. So it enables or has enabled improved travel services through e-bookings and the e-reservations. Then also provides for online employment opportunities. Then we are looking at signals, in bracket data signals. As an introduction, signals are used to carry information from one device to another. They are used to carry information from one device to another, and they can be classified as electrical signals, which transfer information through use of electricity, and also optical signals, where data travels by the way of electric voltage over the optical fiber. So, by definition, data signal is an electromagnetic energy that represents the data flow. And this data can be voice, it can be text, it can be audio, it can be video, it can be any other thing that you may want to send or transfer from one computer to another or one phone to another. Types of signals. The signals are of two types. One, we have the analog signals. Then secondly, we have the digital signal. So analog signals are signals that are in continuous wave that keeps on changing over time period. And the analog signals are further classified into simple and composite signals. Then we also have the digital signals. Digital signals are in discontinuous form, and they carry information in binary formats or discrete values. When we talk of the binary formats or the discrete values, we are talking of the smallest units that the computers understand or use for communication. These units are either represented in the state of on and off. 1 representing the state where the switch is made on, and 0 representing the state where the switch is made off. So meaning the binary forms that we are talking about is either 1 or 0. So the bits, now when we talk of the bits, we are talking of the 1s and 0s. A single character comprises of a byte, and in a byte there are 8 bits. So meaning a single character that may be a number, a figure, a symbol, or any other, including even empty space, has 8 bits, meaning 8 ones and also zeros, combination of them in total 8. Differences between analog and digital signals. For the interest of time, I think the differences are just straightforward. You can just get time and go over it. Let's go to the components of data communication system. In the data communication system, one component that we are going to look at is the message. The communication system without the message will not be a complete one. A message is the communication or information to be communicated. So, the form of information may be text, it may be picture, it may be audio, it may be video, it may be a game. Those are all messages. Then the second component of communication system is a sender. Sender is the device which sends the data message. This device can be a workstation, it can be a server, it can be a computer, it can be a phone, it can be any other thing, so long as the device is able to send information from itself to another device. So the one that sends becomes a sender. Then a receiver is the device which receives or to which information has been sent. It can also be a computer, it can also be a workstation, it can also be a client. So what is a client? I think it is a new term here. In a network, let's look at a scenario where there are two phones being paired together to share a resource. One phone sending a song or maybe a picture, and then the another receiving using a Bluetooth or Xender. So the phone that has the device or that has the file, the picture or the video, the song, is a server. And then the other phone that is prepared to receive the thing yet to be sent is a client. So meaning in a network, a computer that provides other computers with the resources is known to be as server. Then the computer that receives the resources from a client, from a computer that receives the resources from the server is known to be as a client. Meaning for the client, it just receives from the server. A server is like a mother at home from whom the children receive the food, the breast, and so the breast milk and so on. So meaning those children are clients. Then data transmission medium. A data transmission medium is the path through which a message travels from a sender to a receiver. This can be a twisted pair cable, coaxial cable, radio waves, Wi-Fi, and so on, Bluetooth, and so on. And then a protocol is a set of rules that govern communication. It represents an agreement between the communicating devices. Without a protocol, two devices may not be connected together. So, examples of the protocols include the IP protocol, which we looked earlier, the TCP protocol, and the others. The IP protocol is of two types. We have the IPv4, which is the Internet Protocol version 4, and the Internet Protocol version 6. What are some of the activities undertaken by data communication system? There are in the communication, during the communication, the activities that take place there. One is a signal generation. So this is where the sending device generates the signals that need to be transmitted. Then the interface, where the device has to interface with the transmission system so as to communicate and transfer the data over the network. And then we have data synchronization. Is the process of establishing a consistency among data from a source to a destination devices. I think synchronization can easily be also, let's just look at the example. If you you have two phones, you had a phone in which there was a WhatsApp, and the WhatsApp you have been using it. Then God has decided to bless you and you have bought a new phone, another one. Now when you connected the two phones together, you connect the WhatsApp of the two phones, you find the data in the one phone, the WhatsApp of the one phone will have to move to the other. And when you communicate with someone and let it be where the two phones all have internet, you find when the other one is blue-ticked and you also see in the other phone that you are not using, the blue-ticking is done. So that consistency establishment is what we know as data synchronization. Then another activity undertaken by the data communication system is also error detection and correction. In the communication, the system may detect the errors that may be likely to occur and also correct the errors that will occur. So, meaning the system also does its own self troubleshooting, identifying the areas where the errors may occur and they corrects them by them own. Then we have flow control. At the time of transmission of data, a source computer generates data and the destination receives it. So the flow of the data, so it will have to be controlled by the devices in the communication. So addressing when two or more devices share a transmission facility, as a source system indicates the identity and the address of the destination. So let's say you want to send something from your phone to another person in email. There are very many people who have emails, but your thing will have to move specifically from you to another. Or I think that is example. Let's say you have a router and you want to send something from your network to another. So that thing that you send moves from your computer, reaches to the router, and where the router is, the router will search for the address. The address, the internet, the address in internet is just like the PO box number. Like you have been given a letter, this letter will have to be taken to someone who lives maybe in Koboko, and there's a specific place in Koboko. Koboko is a general place, but there's a specific point where that letter should have to be taken to, and that letter is taken exactly to that point, not to any other person in Koboko, and such control is done by the system, such as the routers. Routing, which also means forwarding, is where data is sent to appropriate destination. So with the help of routing, A shortest path among the devices is found, and the data is used to send. The data is sent to the destination using the shortest path being established. Then we also look at the switching techniques. In a large networks, there may be more than one path for transmitting data from a sender to a receiver. So, the act of selecting a path that must be sent the act of selecting a path that must be taken out of other available options is switching. So the switching are of two types. We have the circuit switching, then we also have the packet switching. So sorry. A circuit switching is where a dedicated path is used to send the data. When any node wants to send data, be it audio, video, text, game, or any other, a call request is sent to the receiver, and acknowledgement is made back to the sender to ensure that there is availability of a dedicated path. So this is basically designed for human voice and less suitable for data transmission. So with the help of improvement in technology, then packet switching came in. In packet switching, each information or a message to be transmitted between a sender and the receiver is broken down into smaller pieces. I think we looked at this earlier on. A particular message is broken down into smaller parts or pieces which are known packets, so that these packets can be transmitted independently, maybe using different paths to the destination. So the different packets of the same message may take different routes depending on the available routes. Each packet has at least two parts, that is a header containing the address of the destination and the other information, and the main message part. When all the packets reach at the destination, they are reassembled and the complete message is received by the receiver. So unlike a circuit switching, a channel is occupied in a packet switching only during the transmission of a packet. Differences between circuit switching and packet switching. Circuit switching, it's connection oriented. So in circuit switching, a dedicated path is established between the source and the device and the destination. Meaning, in circuit switching, the two computers should have to be connected with the help of a cable. It is connection oriented. So if there is no physical connection, then the communication will fail. In packet switching, it's connectionless. That is, a dynamic route can be decided for each packet while in transmission, meaning different routes can be used for each packet or for the different packets while in transmission. Circuit switching was originally designed for human voice, but packet switching was just designed for data communication. It's inflexible. Circuit switching is inflexible as dedicated path is established for transmission, meaning data must only be transmitted through the path that has been through the particular path that has been established. So without that path, then data will not transmit. But in packet switching, the case is different. It's flexible, as each packet can travel through different routes to reach its destination. In circuit switching, the switch is implemented at the physical layer, while circuit in packet switching, it is implemented at network layer. Then let's also look at the transmission mode or data flow techniques. Transmission mode describes the direction of flow of signals between two connected devices. The direction in the flow of signals between two devices is known to be a transmission mode. What direction does it take for a signal to move from maybe device A to another? Does it move that way, or does it also come back? Can it move in both directions? That is transmission mode. It is also known to be as a communication mode. So what are the types of transmission mode? There are basically three types of transmission mode. One, we have a simplex mode. Two, we have half duplex mode. And thirdly, we have full duplex mode. So let's begin to look at the types. We begin with the simplex mode. A simplex mode is a transmission mode where data can be sent only in one direction. That is, the communication is unidirectional. Unidirectional. Uni means one, meaning one directional, unidirectional. The communication is only in one direction, not in both directions. So where transmission mode where data can only be sent in one direction from the sender to the receiver, and the receiver cannot send back to the sender, is simplex mode. So unidirectional communication is done in simplex system, where we just need to send a command or a signal and do not expect any response back. For example, in our phones you find MTN sends you a message, and when you want to reply back, you see something there that replies are not accepted, so meaning you cannot communicate back. So just that particular scenario is simplex mode, from the sender to the receiver, and the receiver is not allowed or cannot communicate back. Examples of simplex mode include the loudspeakers. The signal only moves from the radio to the speaker, and the no signal can move from speaker to the radio. Then we have television broadcasting. We have TVs. A signal can only move from the TV station to your TV, but no signal will ever move from your TV to TV station. Then we have a remote. A signal can only move from remote to the computer or to the TV screen to control whatever, to give commands. But now, no signal will move from the computer to the remote. We also have a keyboard, computer keyboard. With the help of computer keyboard, you can press here and there, where the signals move from the keyboard to the computer, but no signal will move from the computer to the keyboard. We also have a monitor, and so on. Second type of transmission mode is half duplex. In half duplex, unlike the simplex, transmission of the data can be done in both directions on a single carrier or a single path or a single line, but not at the same time. So communication can be done in both directions but not at the same time, meaning as it moves from one to the other, then the other cannot communicate, also send the transmission back immediately. So in half duplex, one that can carry data in both directions, but the data can be sent only one direction at a time. Examples of the half duplex is, one example of half duplex is walkie-talkie. A walkie-talkie is a device that is used by police, and also commonly also the radio call works the same. So as the other person communicates, you only hear, you cannot communicate back until it is your turn. Then you communicate with that person here, meaning you cannot also add your back immediately as the other person is not communicating. You at your side, it will break or fail. Then we have full duplex mode. A full duplex is a two-way that is bi-directional. So in simplex we say the uni, meaning one. Bi is now more than one. Directional, meaning the communication can occur in both directions, just like in half duplex, in which the devices can send and receive data simultaneously. Now this is where the full duplex is different from the half duplex. And the similarity is that both of them can send data in both directions, but the difference is that in full duplex the data can be transmitted between the two devices at the same time, but in the half duplex it cannot occur at the same time. So a full duplex is like a two-way road where vehicles can go in both directions at the same time. Example, a mobile phones. When you call a colleague, both of you can communicate and talk at the same time, and all of you hear each other, and that is what we mean full duplex. Otherwise, if it was a half duplex, the two people will talk one at a time. While the other one is talking, then the other one will not. It will not be possible for the other to also talk or react. But in full duplex, the communication of two or more at the same time is possible. Then lastly, for us to close, let's look at the transmission problems. What are the problems that may occur during transmission? We basically have four of them. The other one we already looked at it, that is attenuation. We have a crosstalk, we have noise, and lastly we have skew. So what is attenuation? We said it is the reduction in the amplitude or strength of the final signal as it moves through a medium. It is a reduction in the amplitude or loss of the strength of a signal as it moves through a medium. So as signals pass through a copper wire, some of the signals will be absorbed by the medium. This is also called heat dispersion. Attenuation is measured in decibels in bracket small d and big B. So one way to overcome attenuation is by using a repeater. A repeater is a device that helps to regenerate the strength of a signal as it moves through a transmission medium. For example, if you wanted to send something from maybe Ovujo here and wanted this thing to go up to Nebi, we know that it is not possible for the data to reach as strong as it is at Ovujo to Nebi. So to let this, because of the process of attenuation, because on the way some of the signals may be lost. So to let the signals reach strong, on the way there has to be some devices. These devices are now what we term as repeaters. The repeaters will help to regenerate the strength of the signals where the signals are becoming weaker, and then they regenerate, and then the signals become strong again, and then move where they're becoming weaker, and then the repeater regenerates. So one way of overcoming the problem of attenuation is by using device such as a repeater. So next time when we shall ask what are some of the ways of overcoming the transmission problems, don't say that I have not talked about them. So the second problem is a crosstalk. A crosstalk is where electromagnetic force of one cable has an effect on the other in case of two or more cables being used. So in a communication, if two or more cables are being used, you find once a signal in one of the cable affects the other cable, the performance of the other cable. The electromagnetic force that we talk here is a force. Electromagnet is a force that comes from the data energy. So when two or more cables are being used for transferring data, then the electromagnetic force of one may affect the other. So that problem is known as the crosstalk. But now the way to overcome a crosstalk is by twisting the two wires. That's why there's a cable called a twisted pair cable. So cables being twisted in pairs, and one major reason of twisting those is to avoid a crosstalk. Then next we have a noise as one of the transmission problems. A noise is unwanted electrical signals that find their ways into wires. So let's say, let's look at Arua, and also even we can just look at Ovujo here. Along the road there are lots of electric cables that are hanging in air. So assuming we wanted to connect the laboratories of Marato Secondary and also the laboratories of the school here, and then also the laboratories of domestic Marato Nursing and Marato Hospital. Those laboratories have been interconnected. The computers in those laboratories have been interconnected, meaning there's a network. But sometimes the cheapest way of connecting may be overhead method, where the cables are just hung in air from one to another. So there may be a point where the cable that is carrying the data signals coming together with a cable that carries electricity. So the electric signals from the cable that is carrying electricity may find their ways into the other that carries data. So then such a moment will create a problem, and that problem in the data communication is known to be noise. So one way of avoiding that is by shielding the cables. That's why we have a shielded cables. For example, a shielded twisted pair cable and unshielded, a shielded optical cable and unshielded. The main reason of shielding such cables is to avoid noise. Then last we'll have noise, a skew. A skew is a problem that is related to timing in parallel cables. If data is carried over multiple lines, it is possible that the data may arrive at the different times at the receiver. So this now happens, this is true when we are sending data using the packet switching method, where one piece of message is broken into smaller, one message is broken into small message pieces, small pieces, so that the transmission can be faster. Then the small pieces are transmitted using different paths, and then they are assembled as one message at the receiving end. So as pieces of the same message are broken and sent in different paths, there could be delay because of latency at one of the paths, so making the different pieces to arrive not at the same time. So the problem that is created by that is a skew. So members, for today we stop here. I request you to do a thorough follow-up of the video that I'm going to post, and shortly tomorrow we shall have discussions to understand how the extent at which we have read this particular part. So you expect some questions on this particular area, and the next time we come back we shall begin from computer network. So I dearly thank you very much for taking your time, and may God bless us, and we continue from tomorrow. In the evening, when some of us have come back from work. Good night.